I think that Solana and Celestia share that mentality of like, hey, we need to have abundant block space. Like fees should be low for everyone, because otherwise it's sort of like that infamous tweet that Vitalik did of like the internet of money shouldn't cost like 5 cents per transaction or whatever, right? I actually agree with that sentiment. And so I think Solana and Celestia are very aligned there. But then where they differ slightly is in the emphasis on verifiability.
Well, Nick, thank you so much for joining me. Super excited to have you back on the podcast. It was funny. I was looking at our old podcast, the first one that we did, and I flew to New York City to make sure that I could talk with you and really learn as much as possible about what you guys were doing at Celestia. And honestly, just kudos to you and the entire Celestia team for as much progress as you made. I think at that point in time when I came to New York, you guys were still on testnet. Now you're live, and a lot of things have happened since then. So looking forward to kind of covering that gap, and ultimately looking forward to the future and articulating where's the end road for all these blockchains. So I'm really looking forward to the conversation, and I think the audience will too.
Well, thanks, Logan. I remember that really well. You were just starting out with Frictionless, and I remember you were also starting out with the podcast. And I remember you were like, "No, I want to do it in person." You flew out. That was awesome, and like one of the most technical podcasts I'd done up until that point. And so I think it was a really good like foundation. And I have to give you a lot of credit for everything you've achieved. And also, you were one of the people who was super bullish on Solana back then, right? When things were kind of at their the nadir for the Solana community. And so, I give you a lot of credit too.
Thank you. Well, I think the funny thing, and we'll get into it in this conversation, is it all converges. Solana, Celestia, in some regards, there's obviously some philosophy kind of differences that we'll kind of highlight. But I think to Vitalik's credit, he really articulated the end game fairly well in his blog post. So maybe if we could just start it out there, where do you kind of see the end game of all these blockchain architecture designs, and how is kind of Celestia's point of view, if any, different from kind of these other blockchain architectures?
Yeah. So, we're all trying to reach the end game, right, for blockchain infrastructure. And what the end game is it preserves all like the important facets of what blockchain infrastructure is supposed to provide, right? It should be there should be a lot of throughput so we can support all the different use cases and users around the world. It can be like a global, scale infrastructure. So throughput's a big one. And another one is verifiability, because you need to enable end users to verify the chain in order for the blockchain to actually be worth anything. Like the whole point of a blockchain is that you can audit it and check that everything is happening is legit and nothing is being like cheated or stolen, etc. So verifiability is another major component. And then the last one is this notion of like censorship resistance, or like you can't anyone should be able to access them at any time, and you shouldn't be able to like be excluded. They should be like a universal permissionless platform for people to use. So those are the three things, at least that Vitalik highlighted in his post. And I think so. All endgame, all blockchain infrastructure is like heading in that direction in one way or another. Because if they don't fulfill any one of those, then they've kind of failed at like providing what it is that blockchains are supposed to provide to the world. And so for the first one, to scale throughput, you have to scale block production, meaning you need more block space for people to run stuff on. And there's a lot of different, kind of no matter how you slice it, scaling block production means you need bigger nodes. You could also do it via sharding, where you have lots of different nodes, like smaller nodes with parallel chains. But then sharding kind of has all these complexities. So like, why not just put it all under one like larger network? And I think so that's something that Solana and Celestia definitely share, is like, hey, it's okay to have larger validator nodes, because that's the only way that you're going to scale block space. And you should optimize the crap out of those nodes and that protocol to make it so you can get the most juice. Um,
Maybe if I could jump in there, I think it's been interesting because, I mean, you and I have been talking about data availability for a long time, saying that, hey, you need more throughput, you need larger blocks. And I mean, this kind of commentary or debate has been going on since, I mean, the inception of the industry with Bitcoin and the block size debate. I think it's now interesting that this has really come to the forefold, especially as things start to heat up a little bit within kind of the Ethereum ecosystem and more broadly. Having more expensive block space, I think, is going to be a continued issue, at least for kind of these early networks like Ethereum that may have higher fees compared to a Celestia or a Solana.
Mm-hmm. No, definitely, and that's why I think that Solana and Celestia share that mentality of like, hey, we need to have abundant block space. Like fees should be low for everyone because otherwise, it's sort of like that infamous tweet that Vitalik did of like the internet of money shouldn't cost like 5 cents per transaction or whatever, right? Like, I actually agree with that sentiment, and so I think Solana and Celestia are very aligned there. But then where they differ slightly is, first of all, well, how they define what throughput is. We can talk about that a little bit more. Like, and to me, there's like, it depends on where you are in the modular and the stack. Basically, are you like a data availability layer, or are you an execution layer, or maybe you're both? And so I think we should talk about that in a little bit. But where Solana and Celestia, I think, differ is in the emphasis on verifiability and like and also even maybe how they define that, right? And for Celestia, how we define verifiability is that end users should be able to verify the chain, because it's blockchains are about social consensus. And if an end user doesn't have a way of checking that what the validators are doing is like, actually enforcing the rules that they have agreed to, then they don't really have a vote in the system. They're sort of second class citizens. And we believe in we don't want to have a tiered system here. It's a peer-to-peer network where every peer, every user and member of the network is on the same ground, and it's a level playing field and equal power for everyone. So that's like how we define it. I don't, the Solana definition seems to me more like, well, as long as there's enough full nodes, they will see what's going on and be able to like tell other people, I guess. Yeah. Which I think is pretty flawed, because then you end up in a situation where it's like, well, how am I, if you're making that big of an accusation that like, hey, this chain is broken, then everything has to stop and everyone's going to be like, holy fuck, well, who do I trust? Oh, I trust these guys. Like, it comes back to the same problem that blockchains are supposed to solve from the beginning, to me. So I think verifiability, end user verifiability, is really important. So that's why Celestia does things like data availability sampling. Why we believe in like proof-based blockchain systems, because proof-based is something that users can verify directly. If you have to actually re-execute the whole chain and download every block, then you're never going to get there. But I'll stop there, and then maybe we can talk about censorship resistance.
For sure. So I think most of the audience is super technical, so we probably don't have to explain it to them. But I ultimately like to explain some of these more technical concepts to the average person as well. And ultimately, as Nick and I have kind of been talking about, as kind of you increase the throughput or increase the block size, that is going to really take larger hardware requirements. You can move it. I always say you can't like obfuscate the physics. You can move that from like the layer 1 to like an eigenlayer, or you can move that to like an arbitrum nova. But eventually that like physics of propagating data or having high throughput has to happen somewhere. And when that does happen, to have a full node be able to verify that, because you're having larger resources to ingest, you need larger machines. And so what we're ultimately talking about is the differences of, as these machines get larger and larger, because they're going to be able to process more throughput, both Solana and Celestia full nodes will have large requirements. But today, Solana doesn't have data availability sampling or diet clients, I think in Solana's case. And Celestia very much prioritizes that verifiability, which is data availability sampling that allows anybody to do data availability sampling and essentially act as a full check on full nodes. And correct me if you disagree with any of that.
Yeah. So this kind of gets to the core of the issue here too, right? Is like throughput and verifiability are very intertwined in the sense of, if you want to scale throughput, I think it's pretty self-evident that to scale block production, you need to have beefier validator nodes. And then if you have beefier validator nodes, the full node requirements for the chain, so anyone who wants to verify the chain via running a full node, also increase. So if you want a global scale blockchain with high powered, nodes, full nodes, then that necessarily starts to limit the number of people who can verify the chain themselves, right? And so that's why it's so important to have data availability sampling that allows you to verify it on a phone. No matter how big the chain gets, you're going to be able to verify it on a very, very cheap hardware. And so that's why baking for Celestia, baking and data availability sampling from the beginning was absolutely important, key. And so that's a big conflict. Now, the thing about diet clients, for example, which I think I'm glad to see that the Solana community was starting to move in that direction. The problem with diet client, I think I'm remembering the construction correctly, is you can, as a validator, I think, raise a flag that says, hey, this block is invalid. And if it turns out to be valid, then you can slash me, kind of thing. I think that's what it is. And then people can be running these nodes that listen for that. And then when that happens, they can halt the chain basically until they are able to verify it for themselves. The problem with that is the so-called fisherman's dilemma, where someone could actually withhold data in a block so that the validator can't know whether or not that block is valid. So they raise the flag, and then later they publish the data behind it. And then it's hey, this guy raised a flag when the block actually turned out to be valid, so you should slash him. So this is something that's been known in the research community for a long time. So I think it doesn't solve the same problem. I think the only way to solve this is via data availability sampling. And so I know that what is it called? Tiny Dancer. There was a team doing light clients for Solana, and I know that they were working on some kind of solution to this. But I think it's going to take a lot of work to bake into data availability sampling into Solana.
Yeah, I am curious because ultimately, as we kind of alluded to in the beginning of this, I do very much appreciate the Celestia approach of data availability sampling and the verification aspect. When I ultimately talked with Sam Blackshear, the co-founder, or I believe the creator of Move and the co-founder of Mission Labs, or SWE, they're also creating what they called a sparse node that will track individual assets that kind of that user cares about. So anytime anything happens on chain, they're able to kind of verify that themselves. But I think that Celestia is definitely on the forefront of this verifiability. And I don't know if other chains are going to do exact one-to-one data availability sampling, but some form of verification for at least some assets, or the assets that I care about or select will be able to be verified. Because at the end of the day, as we spoke about, as throughput gets larger and larger and these machines become larger and larger in terms of hardware requirements, it is going to be a little bit more costly to run them to actually get to the throughput that we really want to scale the industry past where it is today, kind of being relatively niche. But I am very excited about ultimately that future that we can get to with kind of these high throughput chains that Celestia and Solana have really pioneered.
I'm just going to pause really quick because it seems, I don't know if you're having this, but my internet seems to be going on and off. It's okay.
I don't know if it's mine or you, because I have it just direct line to my internet, but let me try Wi-Fi because I'm having the same issue.
It might be me. I don't know. I can run a speed test. I mean, I don't know. I mean, obviously I have a shitload of speed, but
I'll turn on my Wi-Fi and see if that helps. Yeah, you're like cutting in and out, and I guess I am too. And then I can like hear you talk about some aspects, and then I'm like, oh shit,
yeah,
I hope he
exactly.
keeps
Yeah.
talking, and then it will like cut back in.
Exactly. Yeah. I couldn't hear some of your the things that you said because they're like freeze, and then I could tell when I was talking that you were frozen, and I was like, oh fuck.
Yeah.
Anyway, let's give it a
cut
try.
it out, like just all these pauses or whatnot. But it was speaking primarily about Sui, like ultimately doing the sparse nodes, Solana doing the sparse nodes, or not sparse node, diet client. But like on a larger level, like we spoke about, and what Vitalik really articulated is at least some form of verification is going to happen on all these high throughput blockchains as hardware requirements get larger and larger, and people want to be able to verify more of the chain, or at least select assets on the chain that they really care about.
Mm-hmm. Definitely. And I think that the modular approach is very sort of aligned with that philosophy, because you don't have to verify all the rollups necessarily. You can just verify the ones that you're using, right? So I think splitting up the state has a lot of like value, not only for being able to have more scalable execution, but also having users be able to just like pay attention to the things that matter to them and not have to like why. This is my main like thing about the monolithic thing is like, why should like, I understand the value of a global atomic state machine. Don't get me wrong. And in fact, you can have that in a rollup. Like a rollup can get really big, right?
We should talk about that.
But why force everything, or why take the stance that everything should be atomically composable when a lot of things will not want to? Certain things will be, for sure, like certain DeFi things. Who knows? We'll see how things evolve. But like, why mandate that all application and all states need to be globally atomically composable? Because that just imposes a massive cost, like as a baseline for everything. And not everything is going to need that. So why not just give the flexibility? Like modularity doesn't say that that's a bad idea. It just says, let the people, the users and the builders choose which things are atomically composable.
Yeah. Let's kind of get into like the Celestia narrative, because both have been doing fairly well kind of within the markets, which anything that goes up in crypto is the new hot thing. Hopefully both of those trends continue, but more so just because of what they enabled than anything outside of number go up. But maybe quantifying some of the stuff that you mentioned and going a little bit deeper into having a single layer 2 as a large kind of atomic system, because I don't think people are now just starting to understand layer 2s. There are just starting to understand data availability layers. Layer 2s have been kind of more prominent for a long period of time, but with high throughput blockchains like Celestia, you can have a single atomic state machine similar to Solana. Can you talk about kind of your vision if that were to exist? I think the biggest call out in my mind would just be how many nodes run that layer 2 within that is settling that data to Celestia.
So I want to, let's lay the groundwork for the sort of Celestia meme. Celestia. I really love. I don't know. I love it that like it just so happened that the two like names like portmanteau very well together. Reminds me of like Saloon Avax, although that's a little bit cursed. Anyway, so what's cool about the Celestia meme is that for the last 2 or 3 years, or like kind of since the inception of Celestia, when we were getting started, there's been this debate, right, between the modular architecture and the monolithic architecture. We're already like, again, like getting back into it just like inherently in this podcast without really thinking about it. And to me, Celestia is sort of like that debate is no longer just theoretical. It's no longer just because it used to be Celestia saying, oh, theoretically, when we're live, you're going to have these benefits, or we're going to be able to like do these new things. And obviously, it had to be all in theory because Celestia was not live yet. But now that Celestia is launched, and we have mainnet, we have actual rollups being deployed, we're actually seeing the modular versus monolithic debate play out in real time and seeing how the different like architectures work, right? And so now it's like the proof can be more in the pudding. And obviously, Celestia is still quite early. It's only been live for 3 months, but that's what it kind of touches on for me. Is like, okay, now like we're each sort of like the flag bearers of the monolithic camp and the modular camp, and it's going to be fun. And honestly, by the way, this is what I love about crypto is that all these different approaches should be tried because they all have validity, right? And then it's about the users and the builders and the open market to decide like which ones work. And it's awesome that we can run all these experiments in parallel because it means that ultimately we get to the end game faster. And like, obviously I believe that Celestia and the modular architecture is the right end game, but what I care more about is that we do get there one day, because I do believe that like blockchains are going to make the world a better place. So, if that's Solana that ends up making that happen, like great,
and vice versa. I mean, from a practical difference, I'm curious what you think if there are any large differences from, say, a Celestia being a high throughput layer, data availability layer that's focused on doing consensus and verifiability or settlement, and Solana doing high throughput at the base layer, less emphasis on the verification, but also really doing executions, consensus, and settlement. Is there too much of a practical difference in your mind from having a layer 2 built on Celestia and settling to Celestia versus a layer 2 being built on Solana and settling to Solana outside of verification?
Good question. I think that Solana, aside from the fact that obviously there's no data availability sampling, Solana does have a lot of data availability bandwidth, right? It has big blocks, and a lot of credit to the engineers who have solved really hard problems to make that possible. But again, like you said, that throughput is not verifiable by end users yet. Maybe in the future it will be. But I think there's other things about the Solana architecture that don't really make it an ideal like data availability layer. Like, as I understand, there's like it's not made for like posting big blobs of data to it. It's not meant for referencing, like quickly referencing that data from the layer 2 and sort of like proving certain things about that data and where it's included and things like that. And it's not also like, so maybe to back up, like Celestia was built from the ground up with rollups in mind, with L2s in mind. So it's like, hey, well, if you started from scratch, you were to design a blockchain that's specifically for L2s, this is how you build it. And some of the things are, one, no execution on the base layer. You want to have as light of a base layer as possible. You want to have no state. You don't want to, because all the L2s that use the base layer have to fully verify the L1 in order to make sure that they can actually like build on top of that L1, right? So you have to, so in Ethereum, this is already a problem, even though Ethereum is so much lighter than even Solana, that all the L2 full nodes need to fully verify the Ethereum L1. And that's actually pretty heavy because Ethereum has so much state and transactions. And it's like a whole, here's how big your L2 is. And then you have to also do all this work for Ethereum, whereas Celestia is designed to be almost no state, almost no execution, so that like it's this very thin thing, and then your L2 is the main thing, right? And you just post data to Celestia, and that's it. On top of that, design choice are things like namespaced Merkle trees, which is Celestia. Every block in Celestia, all the blobs, the data gets organized into a way that's very easy for you as an L2 to find the data that's relevant to you and ignore everything else. And that's really important. So that you can actually like prove things about your chain, and you can quickly sort of like, know the things that are relevant and track track your roll up. And then on top of that are just things like the fee market being designed specifically for that. The transaction sizes being allowed to be very big, so you can customize other things about for example, your mempool. If you know that like a lot of fees are going to be these massive blobs rather than like a bunch of smaller transactions, like it changes all the other aspects of the design. So I don't know all the details of how Solana works, but a lot of that would not really translate over because that's not what Solana was designed for.
Yeah, I am curious just to see if you put a layer 2 on each, just in that roadmap. I mean, theoretically, you could kind of use. I mean, granted, Celestia is much more optimized for layer 2s than Solana, but I'm curious. I know there are a couple layer 2s settling to Solana, and it's
interesting.
not as optimized.
I didn't know that.
There's an exchange actually called Cube. Well, Neil did start out with Eclipse doing like the L2, but now they've kind of pivoted a bit. But I do think there will be more. So I'm curious to see how it will work.
So what I was just describing is if you want to use Solana as a DA layer, right? So I don't think it's designed to be a DA layer, but settlement I'm sure could work just fine.
Or a DA layer.
Okay. And also even, I mean, there are things like Roam protocol, which are trying to turn Solana into like a shared sequencer. I mean, even recently, Justin Drake was posted about Ethereum being a shared sequencer, which is super interesting. Like, I think we're still at the very early stages of really exploring all the different ways in which existing protocols or the existing like technology they've built can be sort of used in a modular way. And like, Eclipse, which you just mentioned, is really interesting because it takes like one of the things that's really amazing about Solana is the Solana virtual machine, the parallel execution, and the local fee markets and all those things. And like the cool thing is you can take all that innovation and then slap it in on a rollup, and all of a sudden it's available. It's not just limited to the Solana L1. It can be set free for anyone to reuse. And that's really the power of modular blockchains too. To me, like I kind of use this analogy of like monolithic blockchains are sort of like top down. It's a more like, I hate, communist way of doing things. It's like centralized control. It's like, the core devs or whoever is in control of like deciding what the spec of the chain is. They decide what features get shipped. Right. And in the modular world, it's more bottoms up. It's about, people are building all different kind of components, and anyone can try anything. No one's gating you from shipping that into production. And it's just like, well, if you think it's useful, build it and then see if people end up using it. So I think it's a lot more of like an organic approach to developing the infrastructure layer of the stack.
So maybe let's go back a bit to the example that we had of like building a Solana on Celestia. To your point, having kind of a open playground to experiment with virtual machines. If we took the Solana virtual machine, put it on as a layer 2 on top of Celestia, you would have that verifiability function, all the benefits that you mentioned with the Solana virtual machine as like with the local fee markets, parallel execution, et cetera, et cetera. I think the interesting thing there is today, the issue that has really arose out of kind of the layer 2 roadmap has really been around decentralization and just making sure that you have enough decentralization at that layer 2. And making sure that today, historically, that is kind of one sequencer. And if you wanted to get to similar levels of decentralization to, say, a Solana of the world, I think they have like 2,000 boxes of like that would rotate. So you'd need 2,000 equivalent is like the biggest differentiator outside of just the pure data availability layers, my understanding.
Mm-hmm. Yeah, that's a very good point. So the reality, and this is actually a very good critique of the modular ecosystem that it exists as it exists today, is this, Mert is always saying like, oh,
champion.
I
appreciate that he does it because I try to be online as much as him, but I pale in comparison.
I know. Yeah. Someone was joking. I saw a tweet the other day. It was like, I don't know, I guess Solana went down briefly, but someone was like, "Oh well, Mert and Ansom's TPS, tweets per second, is like bigger than Solana's right now." And they have a very high TPS in terms of tweet per second. Anyway, Mert's great, and I really think his critique is correct that like a lot of L2s, frankly, are just like trusted. Like there's a lot of trust because there's like a multi-sig or just a single sequencer. And that just doesn't give you very good guarantees. Now, the thing is that all of these L2s, the end game, right, is that they all have proofs, right? And that would really reduce the trust assumptions. And a lot of them are already there. You know, Arbitrum has this, Arbitrum Nitro. You have a lot of ZK rollups that are coming into production. So I think we're getting really close. And so eventually, like that critique will be, you know, outdated. Hopefully in the next year. That's what I hope. But anyway.
And maybe this is a good segue to censorship resistance, because you can create that proof, but once that proof is submitted to the layer one, then it's kind of finalized. But if there's only one sequencer, that could still be technically censoring your transaction. So how do you balance that?
Yeah, so this kind of gets into another aspect of the modular stack to me, which is if you have a single sequencer rollup, or in general, these rollups, right, you want to still preserve good liveness guarantees and good censorship resistance. And there's a lot of different approaches to this. You know, one is, you know, you have an inbox, and that enables you to, as a user, always withdraw to the L1, in a worst case, or exit somewhere, right, if the sequencer censors you or goes down or something like that. And so that's a really important one. But one of the things that is sort of like the most promising solution, you know, obviously you could decentralize your sequencer set and you can have like a bunch of them so that, you know, it's more censorship resistant and there's more liveness, but that becomes a lot more like launching your own chain every time. And so that's why there's this sort of new wave of projects that are building shared sequencers, which are sort of like a sequencer network that gives you censorship resistance and liveness, good liveness properties out of the box without you having to launch your own chain. Or very similar to this is the idea of based rollups, where basically you use the underlying L1 as your like sequencer layer. And then you just inherit the censorship resistance and liveness guarantees of the underlying L1. And in general, again, actually, like we were talking about in the beginning, one of the key properties of the endgame is censorship resistance. And this is something that is hard because, and it connects to another reason why there's going to be centralized block production, is because of MEV. It's very likely that like block production will continue to centralize, even if you have like, you know, 2,000, you know, validator nodes or whatever. Like there's going to be a lot of reasons like why block production, they might be, you know, off-chain builders, or it might be that like all those validators end up like collaborating or colluding in some way to extract more MEV for themselves, things like that. And specifically in the data availability layer context for Celestia, even though most of the execution is off-chain, so you'd think that a lot of the MEV is off-chain, the problem is that there's this thing called profitable censorship, where the validators could like choose to censor your rollup and mess with you as a way to get more MEV for themselves. So that is the motivation for why we need to have really good censorship resistance, because even just having a bunch of different, like a distributed validator set might not be enough in the long run.
So is that kind of expanding even outside of the Nakamoto coefficient?
Yeah, I think it's going to be interesting how it all plays out, but there are new proposals for consensus protocols that bake in more censorship resistance into the protocol natively. There's something called, what is it called? I can't remember, but someone was just telling me about a consensus protocol designed for this. There's this idea of multiplicity that came from this guy in the Cosmos ecosystem. And it's basically about like ending the proposer monopoly, because if you think about it, every block proposer, every validator has a monopoly over that block, right? And so you want to try to like break that monopoly and make it so that like you get much better censorship resistant guarantees. And so I think that's not really that important yet, but it is very important, but it's just like, I think that becomes really relevant later on, like maybe in a few years or something. But we should start working on it now.
Yeah. I think Solana and some of the newer execution environments, they have DAGs, and so they have multiple leaders that make the essentially monopoly. Instead of one leader always controlling MEV, you can pick different nodes or hopefully the closest geographical leader to you so that you have lower latency, but you ultimately have a little bit more competition, so to speak, for block production.
Mm-hmm.
But
yeah, that sounds really interesting. I'd love to read more about that.
It is all interesting. I'm very curious to see where it all ends up. But we've been going a little bit nerdy for a little bit, so let me try to bring it back up and talk about kind of where you see the industry ultimately kind of going from an end state. We've been talking about the different trade-offs, predominantly from like the more modular versus integrated chains. But I believe me, and correct me if I'm wrong, you very much see this world of like this proof aggregation endgame. And I think Polygon really recently announced something similar where they're doing aggregations of proof. Could you maybe expand upon that vision a little bit more and how you see that world ultimately ending up?
Absolutely. So one of the main complaints, right, that the monolithic people levy against the modular architecture is this idea of fragmentation of state. And like, all these rollups are going to be these little islands of state, and like interoperability and bridging is still very janky and trusted and slow. And so, you're just like you're really compromising on one of the other value props of blockchains, which is like, state should be interoperable. And I completely agree with that. And so that is something that I think Solana in the near term has an advantage over, is like everything being interoperable and atomically composable. But what's really amazing is that in the modular stack, we have a solution. And that is proof aggregation. And the thing is that solution is going to be is really hard to execute. But Polygon, I was really surprised when they announced that they're already working on it. They have like an MVP of it that they're going to launch supposedly this month. And essentially, what proof aggregation is the idea that you can take a bunch of state proofs of a bunch of different rollups and then fold them all into one, root proof that each one of the rollups then can verify. And what's beautiful about this is like, okay, let's say you did have rollups and they were able to bridge with each other. First of all, you want to make it trust minimized, so they're not just like, it's not just multi-sig. You want to actually verify each other's state. But then when you do that, you have to worry about what is the topology of this bridging? And is it going to be a hub and spoke, or is it going to be like, a nested tree of bridging? And then you have to you have all these different paths, and so that you fragment the actual which assets are canonical and which chains, and you have to do all this hopping, and it gets really ugly, and there's a lot of overhead because every bridge, in order to verify the other chain, has to do a certain amount of work and posting block headers, and it becomes really bad really fast. And so a lot of monolithic people, including Kyle, rightfully critique that vision. And the cool thing is that proof aggregation can solve all those problems, because it's an all-to-all bridge between all those rollups that participate in that aggregation, essentially, where by verifying one single proof, I can now verify the state updates of all those other rollups with just one proof. And I don't have to do more work for each new rollup that wants to join in and bridge to me. And I don't have to worry about the routing and all the complexities, because it's just each bridge is literally direct one-to-one. So it's a beautiful vision for how we can unify the state and unfragment, solve the fragmentation essentially that's inherent in a rollup centric world. And by the way, also I want to just give a shout out that Vitalik is sort of the person who first. I mean, I had talked to teams like Sovereign SDK, Sovereign Labs about this kind of idea, but Vitalik really articulated it extremely well at Modular Summit last year. And it was really a badass speech. So if people are interested, they should watch that.
I did watch that talk. It was very interesting. Proofs on proofs on proofs. In the kind of aggregation world, where does this aggregation actually happen? Is it going to happen at kind of the Celestia on the layer one? Would that happen at kind of the decentralized sequencer level? Like, where in the stack does that actually live?
Really good question. So, I tweeted something about basically to the effect of proof aggregation is the end game for like the settlement layer, right? And the reason I said that is settlement, what it really is about to me is about bridging, right? And unifying liquidity, allowing state to, interoperate with each other. And like in the old world, or even like, the way that things work today is, Ethereum, for example, is a settlement layer. You have all this liquidity there. All the rollups sort of like roll up into that, and then they can bridge between each other in theory. But the with proof aggregation, it's no longer that you need like a specific settlement layer. It doesn't need to be a chain. The settlement is just the fact, like it's more sovereign essentially, because each rollup is able to do its own settlement by just verifying that one proof. Like the settlement is the proof, if that makes sense. And so it almost doesn't. You don't even really have a settlement layer in that case, which is kind of interesting. Like because each rollup is doing the settlement by just verifying the proof, and this really aligns with like Celestia's long-term vision, and is also kind of why, in some ways, I've never felt totally confident saying that settlement is a like layer in this. It is a component. It's an important part of the stack, but it's not like, it doesn't have to be a layer. It doesn't have to be its own chain, because settlement can be sovereign in a sense and like handled by the chains themselves.
So, forgive me, I'm still a little confused.
Okay.
So forgive the stupid questions if they're dumb.
No, they're definitely not. I'm probably just like rambling and like sound like the guy with the whiteboard, who's like.
So for example, say there's 10 rollups built on Celestia. The first rollup creates this proof. How does that proof ultimately get shared with rollup number 2 and rollup number 3?
Yeah. Okay. This is where I wish I had a whiteboard. I mean, I have a whiteboard here, but I don't want to like mess up my setup. Anyway, so, okay, think about it this way. By the way, I didn't mention that a kind of prerequisite to this working is that, in order for these rollups to be part of this proof aggregation layer, they have to be ZK rollups, right? So, each of these ZK rollups generates a proof saying, hey, this is the new state of this chain, and I can prove that this is valid. And it might even have a reference to like, I can also prove to you that the data behind this is in a Celestia block, for example, in this Celestia block. And if you sampled that block, then you can trust it. So they have that proof. Let's say you have 10 of these ZK rollups. They each generate that proof. So you have 10 of these proofs. Now you have a recursion step where you take 2 of these proofs and you prove that they're both valid. So now you have a proof that proves both of these proofs. and then you just recurse up until you're left with just one proof that proves all of them at once. And now you take that one proof and you, on this single ZK rollup, it verifies that proof. And then within that, it can know, okay, this is a state on all these other 10 rollups. Oh, this guy just, did a cross-chain, action that I need to update my chain for, and vice versa, if that makes sense.
So like an example is, and again, going back to Celestia, 10 L2 rollups, rollup 1 and 2 each create their own proof, and then they essentially communicate together within that and create a kind of higher proof, aggregating those. Rollup 9 and 10 each create their individual proofs and then create a shared proof. Same for the other rollups within this, and then ultimately at the end you have one rollup that would get submitted to the layer 1.
Yeah, well, it doesn't have to be submitted to the layer 1. Each rollup can verify that single proof. Does that make sense?
Then that would just be, once you get all the layer 2's proofs aggregated, then you would redistribute that to all the different L2s to verify that this one proof is holistic of all the proofs aggregated.
Yeah, exactly. So that rollup, by verifying that proof, is essentially has a trust minimized bridge with every other rollup whose proof was included in that master proof, if that makes sense. And then just to touch on like the settlement part and Celestia specifically, interestingly, although unrelated, Celestia is exploring the idea of adding what we call ZK accounts, which are special accounts in Celestia that instead of being able to move or spend the funds or do certain things by verifying a signature, instead it depends on the verification of a ZK program. And so if you present a valid proof rather than a signature, then to this account, that will enable you to do certain things. And so the reason that this is so powerful is in some ways it allows for settlement on the Celestia base chain, kind of. But really the use is that you can now move like TIA tokens from Celestia up into the rollups in a trust minimized way. Whereas right now, in order to bridge TIA to rollups, you need to actually go through IBC or some other like not direct, not fully trust minimized way of doing things.
Interesting.
But the goal is not for Celestia to be a settlement layer, by the way. Yeah. It's not like we're settlement pluralists. Like it's the same thing, like build whatever. It's like, and I think that's actually something that makes Celestia so powerful, right? Is like we can let Ethereum be the settlement layer. ETH-L2 is built on Ethereum. We supply the DA. Like that's what we care about, is supplying the DA. We can even allow Bitcoin to be a settlement layer. I was just thinking about today about the BitVM stuff and how with BitVM now we could verify our Blobstream X off-chain DA system on Bitcoin. And all of a sudden you can have Bitcoin be this like settlement layer for Bitcoin L2s. And I think that like plurality is really the kind of what we believe in. So I want to make that clear.
For sure. I think maybe the other kind of big differentiation between, say, Celestia and Solana or some of the more other integrated blockchains is the idea around kind of having a single execution environment really dominating the vast majority of activity, instead of having hundreds, thousands, or millions of different layer twos. And I think ultimately that probably boils down to, well, it used to be local fee markets, just making sure that you can have multiple applications live in with kind of one shard and kind of dynamically allocate those resources and the pricing within them. But I think even outside of that, the larger point of the Celestia community, and again, correct me if I'm wrong, is more that, hey, you should be able to build whatever you want. And that flexibility is ultimately what will really be the proliferation of thousands, if not millions, of different layer twos, because engineers are going to want more of that customization or flexibility.
Yeah. So this touches on, and back to like Solana, Celestia differences is we really firmly believe in there's no one size fits all, right? And I think, Solana's like, that, hey, the SVM is enough. Like you don't need more. Just use this out of the blocks, right? And Celestia is more like it's about build whatever. It's that the best applications are going to come from people who want to go in and choose each of the different components to reach a spot on the trade-off curve that is uniquely suited for that thing, right? Whereas like if you build on a monolithic architecture, you're kind of stuck for the most part on that one trade-off curve, trade-off point that's been chosen for you. So I think customizability is like inherently like just essential to building compelling apps in Web3. And so, there's certain things like being able to customize your execution environment, your VM, to, let's say, add certain account abstraction features or some kind of fee, like different fee rules. Or for example, there's like this change to the EVM that allows you to natively use like the secure enclaves in phones as your wallet, that allows like way better user onboarding. There's a lot of like cool things like that allow you that you can only do in a modular architecture, the modular approach, and that customizability that brings. Another thing that's really important is just the like monetization, right? So if I'm building an app on a shared execution layer, all the execution fees are going to that L1 or whatever execution layer that is. It doesn't have to be Solana. It could be even, Arbitrum 1 or the Optimism, mainnet chain. And there's a lot of incentives for those apps, if they become successful, to migrate to their own chain where they can internalize those execution fees rather than just like dumping them into whatever execution layer. And so like you can actually make, as a developer, a significant amount of money if your application has traction, because you're able to capture some of the economic value that you're generating. And so I think that those are some pretty big reasons why the modular approach is so compelling to builders.
I think going back to our earlier point, a lot of this I do think will ultimately converge. What I'm seeing kind of more in the integrated stack is more customization or more flexibility, whether to capture MEV for different applications in the application smart contract level, or even some things that ultimately got shipped with Solana in terms of token extensions, trying to make the general purpose chain more customizable over time, while Celestia is saying, hey, you can do whatever you want right now, immediately today with your own layer 2. There's a billion permutations, go for it.
Yeah, I actually haven't had the time to go deep into the what was it called, the token
extensions. It used to be called Token 22. As engineers are great at naming things, but it got revised, I think, by marketing to token extensions.
I think marketing, made a good call there. But I read the like tweet thread, and I watched a bit of the video, but I haven't been able to like go deep on it. But I was pretty impressed, and it sounds really cool. And I think it's awesome that they're sort of enabling more customization at the base layer. But my take on this is that you're always going to be more limited in terms of customizability when you're building on a monolithic stack, right? And that's just, I think, inherent to the system. And so, but maybe it's like, maybe the amount of customization that you need is, only goes so far, and you're able to get 98% of the way there just with token extensions, for example. And in which case, maybe the trade-off is fine. And so I think like we'll see how both of them play out. If but there's also things like, even for example, I can in the modular stack, I can choose a different shared sequencer sort of technology that allows me to customize things around, like, okay, I can have a private mempool. I can have really, really fast confirmation, soft confirmations, and all these things that, like, again, token extensions, give you this layer, this amount of customizability on this layer of the stack, whereas the modular stack gives you customizability over the full range. And so I think, but again, maybe there's going to be things, I don't know, Solana continues to surprise me. So there could be things that I'm not aware of.
I'm convinced, Nick, we agree on a lot of things. I think we ultimately just coming at it from different angles. But I do think, like, as we've talked about a lot throughout this podcast, I feel like they're going to converge, just ultimately approaching kind of the engineering from different ends of the spectrum. And as we both agree, each of these different sides should be applauded and should be explored, because ultimately what we're both trying to do in the different approaches to scaling blockchains is bringing more users on chain to actually hit the level of scale that we want. Maybe in like the last couple minutes though of the podcast, I really do think you've made, not you specifically, but the Celestia team as a whole has really made tremendous progress since our last podcast. Is there any kind of like insights that you could give to engineers or builders, just kind of the grind, whether that's kind of going throughout the fundraising process, surviving the ups and downs of bull markets and bear markets, or just shipping and kind of iterating?
Uh-oh. I'm frozen. Okay, I think I'm back.
Did you catch the last part?
I didn't catch the full last part. Why don't you say that again? Sorry.
So ultimately, I just kind of moving forward in terms of like the conversation, and as we're wrapping up, I think you and the Celestia team have made tremendous progress. Like since we last spoke in New York, can you share more of just like any general advice that you would give to founders, builders, like through the bull markets, through the bear markets, through either fundraising? A lot of people look to Celestia today as really a pioneer of what's possible. And would love to kind of get your insights, and whether that's managing teams, engineering, kind of the whole gamut.
Well, I have to say I can take almost no credit for the progress of Celestia. I'm just one person on a very talented, diverse team, and I'm also not even. I'm an engineer by training, but I don't do any engineering. So all the amazing tech that this team has built, like I had no part of that. So like I'm just a humble, I don't know, I guess like COO anyway, but. My advice, and thank you also, by the way, because it has been a lot of work, and Celestia has been a project that started actually in 2019 when the Lazy Ledger white paper was published by co-founder Mustafa, and it was a grind. I mean, in the beginning, he couldn't fundraise. It took like months, I think, and like tens, like 50, more than 50 no's basically before anyone even wrote the first check into what was then Lazy Ledger. And in fact, the person who wrote the first check was a dude in his dorm room. And wow. Like, because no one, I mean, back then, no one knew what data availability was. B, rollups weren't even really a thing yet. So this whole idea of like a data availability layer was like just made no sense to people. And also that was kind of peak ETH maximalism, not in a sense, not in a toxic way, but people were just like, well, Ethereum is the execution layer, that's already kind of
because
won.
If you talked about any execution environment outside of EVM, you're almost crucified.
Shit, I froze again. Say that
no
again.
I was saying, I remember that time, because if you talked about any other like L1 or even any other execution environments, you're almost crucified.
Yeah, exactly. I mean, I'm sure the Solana community can very much relate to this, right? That like, any alt, like alt L1, which is still kind of a dirty word or whatever. Like that was like the peak dirtiness of that word of like, well, why does it even matter? Who needs that, right? Because again, it was a bear market. There wasn't very much transactions, and like Ethereum was fine. Anyway, I felt like Ethereum was invincible, and so it was like, why would anyone fund this weird data availability thing? So anyway, I guess what I'm trying to say is like, it's been a long, long journey. So you have to really believe in what you're doing and be committed and be able to withstand the depths of like negativity and pessimism and cynicism when you're going through these bear cycles, because it's very easy to fall into that, especially when there's things that are genuinely make you question the space, like things like what happened with FTX last year. Like a lot of people genuinely just kind of left because they felt that that was a sign that this is all kind of a sham, right? Whereas I believe that the whole FTS thing was actually just a symbol of like why we need to build these systems, why verifiability is so important. If end users could have at any time verified what was happening on FTX, then that never would have happened. As soon as the first fund was moved and used for the wrong purpose, it would be like everyone would be aware, right?
That is true.
So I guess having what I'm trying to say is like Celestia was a really long project. It took us a long time to get here. So there's no like such thing as overnight success, and it is a grind. And I just remember also when I got into the space in 2017, feeling like, wow, I'm so late. It was like everything's already done.
Well.
Yeah, everything's done.
Felt super late.
Yeah, and it's like, wow, I don't know, is it even worth it? Like, it seems like it's already done, and now like I still feel that in 2024 we're still extremely early. So if there's people out there who are thinking about getting into this space, I think we're in a really, really exciting time, because there's like I feel like the infrastructure layer is finally reaching a level of maturity where interesting applications are going to be possible, and they're not going to end up falling flat when they get any kind of traction. Because like if you think like the history of crypto is like every time there's an application that kind of gets this like cool excitement and product market fit, it like one of a few different things happen where it just scale fails essentially. And now I think we're kind of getting past that. And so I'm really excited about what the future holds for the space. And like, it's a really, really ripe time. And you don't now you don't have to necessarily be some like Giga Chad protocol dev guy to do something interesting. Like you can build compelling user facing applications on the stuff. And like, I love that emphasis that Solana has on like, hey, users first, make applications, like consumer grade applications. And I think that like the whole space can really take a bit of that, internalize a bit of that, because like sometimes we're just too, that's like what is it called? It's like an all you can eat like nerd buffet of like, oh, well, let's just like nerd out about like the details of like how to define L2s, or, I don't know, what's the best optimistic rollups better than ZK rollups, or, oh, well, I don't know, all those like various like technical debates that, while valid, like sometimes we just get a little bit like we just bike shed a little too much at times,
I agree. I totally agree with you. I think in terms of kind of where new focus is going to go now that we have high throughput blockchains, you shouldn't hit kind of that scale fail. You shouldn't have these anti-network effects where applications do become large and then the network suffers. So I'm extremely excited. I'm excited for what Celestia is doing. I've always said I think Celestia is the pioneer in verification. And I think that, to your point, FTX wouldn't have happened if people could verify. And so that aspect, I think, is only going to be more and more pertinent. I think to highlight kind of our entire conversations, taking these different approaches towards high throughput blockchains, I'm very interested to see where the end game is and kind of having the convergence of all these ecosystems. But it's an exciting road, and really appreciate you, Nick, coming on, being a champion, not only for Celestia, but for helping the industry scale. I think, to your point again, this technology is extremely powerful, and we should really try to get it as in many people's hands as possible, which I'm excited about. Now that is a realm that is now a possibility where before it didn't look so bright.
Yeah. We still have a lot of work to do, but it feels possible, and it feels like we're on the cusp of getting there. And again, thank you for having me on, and big respect to the work that you're doing, and to all the whole Solana community, and the monolithic versus modular is all just like it's a small debate within like this bubble that we're in. And really we should be focusing externally on growing the pie and bringing more users. So with that, we are very aligned.
Cool. Well, thank you again for coming on the podcast, Nick. It was a lot of fun and a great conversation.
Likewise.